So in this video, we're going to be talking about how to describe some characteristics of square root functions. So what we want to do is we want to be able to match a square root function to its graph. So to do this, what you're going to do is you're going to graph the given square root function using your calculator or Desmos, then compare the points on the graph. If the points match, then you know you have the correct equation and graph. So let's look at an example. Which of the following is the graph of f of x equals the square root of x minus 3? So what I'm going to do is I'm going to go over here to Desmos. I'm going to type f of x equals, and then remember to get the square root button, I need to click down here for the keypad and then click square root and then do x minus 3. So once I do that, it gives me my graph, which I can now match to what I have over here on the right. So what you want to do is you want to click on some points. So for example, this graph starts at 3, 0. So I know that A and B won't work. C does start off at 3, 0, and then D does not either. But just to double check, you want to match a few other points. So for example, I see the point 7, 2. And if I go over here on my graph and I can find that point, I can verify that it is the same graph and it does have that point. Okay, so that's how you can use Desmos to figure out a graph given an equation. So now you can try this example on your own. So go ahead and pause the video and then try this example. So to do this problem, you're going to go to Desmos once again, and you're going to type f of x equals, and then from keypad, choose square root, and then do x plus 1. So once you have your graph, you can see once again, this starts off at -1, 0, and it contains the point 0, 1. So let's look for a graph that has these same features. So this graph has 0, 1, but it does not start at -1, 0, so A won't work. B looks like it's good. Let's just check C. C doesn't work because it does not have the same x-intercept. And then D is over here at 1, 0, so that won't work either. So B is the correct answer. So you can also determine a square root function given some points. There are two ways you can do this. The first way is to test the points by plugging them into the given equation for x and y. If the values make the equation true, then the equation is correct. Or you can graph the equations and determine which graph contains the given points. So let's look at an example. So it says a square root function has an endpoint at 4, 0 and contains the point 13, 3. What does the equation of the function describe? So if I was going to use the first method, I would start off with one of my points. So for example, the point 4, 0. So that's x and this is y. And then I would plug into my equation and see what makes my equation true. So for example, if I plug into equation A, I get 0 equals the square root of 4 minus 4. So that gives me 0 equals 2 minus 4, which is 0 equals -2. So that's not true. Then if we try equation B, we have 0 equals the square root of 4 plus 4, which is 0 equals 2 plus 4, which tells me that 0 equals 6. So that's not true either. So if we try C, now we get 0 equals the square root of 4 minus 4, which tells me that 0 equals the square root of 0, which is in fact true. If we try D, we get 0 equals the square root of 4 plus 4, which tells me that 0 equals the square root of 8, which is not true. So C looks like the correct answer, but let's check the second point, 13, 3. And if we check that point, once again, that's x, and this is y, and we get 3 equals the square root of 13 minus 4, and so we have 3 equals the square root of 9, and 3 does equal 3. So that is why C is the correct answer. You can also verify this using the second method. You can enter this equation into Desmos. Y equals the square root of x minus 4. And then when you look at the graph, you can verify that it does contain the points 4, 0 and 13, 3. So 13, 3 is right there. So now you can go ahead and pause the video and try this example on your own. So if you do this, if you try it with a first point and you try x and y, you'll notice that it does make the equation true. If we plug it in, we get -3 equals the square root of 0 minus 3, which is -3 equals 0 minus 3, which tells you that -3 equals -3, which is true. You can double check with 25, so you get 2 equals the square root of 25 minus 3. So that's 2 equals 5 minus 3, which is in fact true. So you can also find inverses using the points on a graph. So you can graph an inverse using the points on a graph. You can start off by graphing the original function and creating a table of points. And then if you swap the coordinates, if you reverse the x and y values to create a new table, that will create a graph based on a new table. And that new graph will be the inverse. Be careful to watch out for restrictions. Remember, if you have things like square root functions, you don't want to have a negative x value. So just be careful with that when you're switching the x and y values. So let's look at this example. Let's graph f of x equals the square root of x plus 2, and its inverse, f inverse is x squared minus 2. So you can find these values by plugging them in, or what you can do is you can go to Desmos, and you can do f of x equals, let's do the square root and square root of x plus 2. And then you can find these values. So at x is -2, we have a value of 0. If x is -1, we have this point right here. Let's see, -1. One, so 1 is the next point. And then we have 2. So that's my next point. And then we have 7, which is 3. So what we can do now is we can take these x and y values and reverse them, and that can create the graph of the inverse function. So what I do over here is all my y values, I'm going to copy into my x column. So I have 0, 1, 2, and 3. And then all my x values, I'm going to copy into my f of x column. So I have -2, -1, 2, and 7. So when I plot these points, so I have 0, -2, 1, -1, 2, 2, and 3, 7. So this gives me half of the graph of the inverse. So this is the graph of the inverse. If we type this function into Desmos, we can see that it is a parabola. And that's what I was saying with domain restrictions. So what happens is, since the square root function, we had to restrict the domain on the original function. When we do the graph of the inverse, it only gives us half of the graph. So you can fill the other half in, because remember, it's going to be a mirror image. So we just draw it in, and that is the inverse of this function. So now you can go ahead and pause the video and try this one on your own. So if we're doing the square root of x plus 5, these values over here, this will be 0. You should get 1, and then 2, and then 3. So we're going to reverse the values. So the y values are going to go into the x column. So we have 0, 1, 2, 3. And the x values are going to go into the f of x column. So we have -5, -4, -1, and 4. So once again, we're going to graph these: 0, -5, 1, -4, 2, -1, and 3, 4. When we graph it, it gives us half the graph of the parabola, but we can just go ahead and draw in the other piece right here. So that is the graph of the inverse function. So what is the relationship between the domain and range of a function and its inverse? So notice that the domain of a function is the range of its inverse. The range of a function is the domain of its inverse. So you can see here we have the two inverse functions, f of x equals x squared, and then f inverse of x is the square root of x. Notice that the x values become the y values of the inverse function, and then the f of x values become the x values of the inverse function. Notice that the only value that did not get transferred over is this -1, 1. And the reason is because we have that restriction when we're doing the square root, okay? When we're doing the square root, we're only taking positive square roots, so that's why we can't have a -1 in our F inverse X column. So just be on the lookout for that. So even though we're swapping the X and Y values, be careful when you have domain restrictions going on. So you can identify points on a graph using your graphing calculator or Desmos to match a function to its graph. You can generate the graph of an inverse by switching the X and Y coordinates of each point, but remember to watch out for restrictions. The domain of a function is the range of its inverse, and the range of a function is the domain of its inverse.